Hello, everybody. Thank you for participating in today's Zoom meeting on evolving our understanding of Pompe disease, data-driven insights. Today's guest speaker is Ryan Colburn, and I'm sure most of you already know him. Ryan has some genetic variants, just like everyone else. In 2015, he learned that some of his variants are associated with a rare metabolic disorder and has unapologetically altered course ever since. His professional background is in development, engineering, and operations management as applied to race cars, airplanes, rockets, satellites, and now rare diseases. He's a driven student of process. It's everywhere. And in this context, applying what he's learned along the way to contribute to the health of the rare disease ecosystem. He's passionate about empowerment and engagement and shifting the view of patients as subjects to one of participants, collaborators, and partners who can help to find the most effective ways to accelerate progress on understanding and solving challenges in rare disease. Ryan will get started in a minute, and along the way, if you have any questions, please use the Q&A or the chat box at the bottom of your screen, and Ryan will answer them at the end of the presentation. And with that, thank you. And there you go, Ryan, it's off to you.
Thank you, Tiffany and AMDA for having me. This is a topic that I'm very passionate about, data-driven insights to help understand and uncover new insight into new understanding of Pompe disease and rare disease in general. And I hope that I will do an okay job today of sharing some of that passion with you. And so let's jump into it. So in life, in science, in Pompe, we have these puzzles, and we're collecting pieces all the time. And these pieces are information to help us learn something about what's in each of those puzzles, let alone the bigger picture puzzle that each of those smaller puzzles is a part of. One notable difference is that sometimes we don't have the box lid to reference on how the puzzle's supposed to look, or what shape it is, or even how many pieces there are. So let's use an example of a literal puzzle to visualize some of this. And I'll give a hint, this puzzle is a picture. Each puzzle piece is information. It's data that helps us to understand the picture. Does anybody want to guess what this picture is? And I know we can't chat, but remember what your guess is, write it in the chat, etc. You've got a ton of information right here on the screen. I promise you this is a piece of the picture. State your guess. So we'll have a smooth transition to math now while you guys are guessing. And I've got my fingers and toes crossed here that y'all won't give me wedgies for being such a nerd. But statistics can help us quantify how good a snapshot is at representing the whole picture. And a regular piece of that comes from two types of error. Type 1, which is alpha error, and type 2, which is beta error. So coming back to our puzzle, who knows what it is now? It should be easy. We have twice as much information. And to imagine those error types from a minute ago, if I told you that this whole image is blue, one of those error types is the risk of not accepting that it is blue when it really is. And then the other type of error there is the risk of accepting that it is blue when it really isn't. All that to say is that both types of error can trip us up. So it's helpful to consider both when looking into this kind of thing. Got another piece now. Ooh, it's a corner piece. That's extra data beyond just the image there. It also tells us that, gives us some idea that this puzzle is a square or a rectangle. And again, we're collecting more information all the time, but still probably not enough to make a good guess. And now I'm really confused because all the other pieces were blue, but those ones aren't. And so in real life science Pompe puzzle, we don't necessarily have much information at the start. But I can give you some more hints. Each of the pieces on the screen right now is in the right place. And I can also tell you that there's 180 pieces in this particular puzzle. And I'll ask again, does anybody know what it is yet? Write your guesses in the chat. Hold on to them in your head. We're going to come back to them in a little bit. And as you think about that, how many of those 180 pieces do you need to feel confident that you know what the picture is of? What happens then if there's a consequence to your guess? Does that change what your confidence level is? For example, if it costs time or money or impacted people's lives, how confident do you need to be to act on your guess? I think by now you get it. I'm a nerd. So we'll pause here for a window in what this has to do with Pompeii. But as we do, remember this view, these 5 puzzle pieces, because we'll reference it again pretty soon. So how do puzzle pieces relate to Pompeii? Sometimes it feels like we know a lot about Pompeii, and it's overwhelming to learn and hard to keep up. And yet other times, it feels like we have a lot of questions which we don't know the answer to yet. One of those questions for me was, how many people have Pompeii? And initially I accepted the answer as 1 in 40,000. And then newborn screening started. And as data started to trickle out from Taiwan initially, and then some of the states, the numbers were quite different. And I got really excited because I just knew that a better answer to that basic question was coming. But it didn't come. Rather than actually using that new data, there was just this asterisk added to the conversation that said, the data from Taiwan doesn't apply because it's different there, and it's probably different in certain populations. But again, all of that not using the richness of the new data that was coming out. And initially, I grew frustrated by all of that good data being generated, but being dismissed. And so I kind of decided that rather than let that feeling continue to fester, I wanted to play with the data and see how doing so might help with the puzzle. And so this is largely this is an oversimplification of all the cool things that epidemiology is, but it's the study of patterns or determinants of health related to a population. So the related items that you might have heard of that talk specifically about this are prevalence or incidence or frequency. And there's some subcategories and distinctions from each of those that I've learned along the way. But this is just enough to get us a taste and a start. And so epidemiology, or epi as the cool kids call it, is more than just about these terms, but this is where we jumped in on this work. So why does epidemiology matter? Each of these things listed here is really important to improving the health of our ecosystem, but I've emphasized a few that stand out for me as crucial. So epi matters because it tells us how many people have Pompeii, which is that basic first question. But we also know that diagnosis itself, identifying people with Pompeii, and giving them the gift of that diagnosis, is a bottleneck to actually being able to help them. We can't help anybody until we identify. And so it helps us to understanding improved epidemiology is a helpful reference for how well we're doing on diagnosis, and it helps us to identify strategies to improve diagnosis and reduce delays. It also helps us understand how we study Pompe disease, what participation might look like, what natural history might look like, et cetera. It motivates investment, and you know, this one feels a little bit crass sometimes, but the reality is that if we can make a business case for why helping people is good, that only helps to incentivize people who want to do good things in the world by being able to make a good business out of it. So it motivates investment into further research, into therapeutic development, et cetera. And then it also supports regulatory and payer discussions. And for me, this last one's pretty important. It represents that box lid for our puzzle. The more that we know about what our puzzle looks like, the better we can strategize how to go about solving our puzzle. So strong epidemiology is the basis for future learning and strategy, and it provides a sanity check on conclusions and strength of conclusions, so that we can use those things as reference frames for metrics or feedback on how we're doing. So back to our puzzle. We've got a new piece that looks like it has a person on it, and that's a lot of new information. Just like that corner piece gave us extra information more than just the image on the thing. This one starts to tell us, perhaps along with the other piece of information, we have a person there. And there's some more people now and a tree. And the good news is we don't actually need all of the pieces here to make significant progress on the puzzle. We've got a lot to go off of here. We've got the information that we know the total number of pieces of the puzzle. We know that all the puzzle pieces are in the right place. We know that it's a square. We know that it's a picture. We know that there's some people in it. The blue is up top. The green is at the bottom. That's probably sky and grass. We can start to make increasingly intelligent guesses at what this picture is actually of. And the same thing is true in Pompe and in Pompe epidemiology. So there's a lot of there's a lot of babies that have been screened for Pompe by now. As of today, we're in the neighborhood of 23 million babies worldwide screened for Pompe. And what we're showing here is data representing 12.6 million of those screens that have taken place across 35 programs in 9 countries and on 4 continents. And we see this really interesting thing, which is expected in statistics, that the spread amongst the programs on the left is quite large. So on the left side of the screen there, everything's really spread out, and that's the side of the screen that has small amounts of data, small number of total screens in that program. But as we move to the right, increasing the count of the newborn screened, that spread amongst those different places seems to tighten. And it turns out Taiwan isn't really that different. We just had our minds closed to the rest of the puzzle. And I'll just point out that Taiwan, I don't know if you can see my cursor there. I won't lose you. It's on the right side. Taiwan, New York, California, the places that have the highest number of screens total really start to tighten. And so in fact, 82% of the variability that we see in all of these 35 programs is explained by a single variable linear regression model that has sample size as that variable. That's a complicated way, a nerdy way of saying the vast majority of differences seen between programs is explained simply by how mature the program is, how many babies they've screened. So indulge me for a moment. We're getting into some numbers here. So the numbers of what we're looking at. Sorry. If it helps for folks that don't follow all the numbers, this part of it should give you the confidence to correct and update anyone that still uses 1 in 40,000. Some quick history. The 1 in 40,000 numbers comes from 2 different efforts taken by 2 different groups in the late 90s to update the previous established Pompe prevalence at the time, which was 1 in 100,000 to 1 in 160,000. Both of those studies took the approach of screening a random population to identify carriers of variants known to be disease-causing, and then using a principle called the Hardy-Weinberg principle to extrapolate how many people had Pompe from those carrier screens. So in the table here, we can see sample size is the number of people that they screened. Variance considered is the total count of the variants or mutations that were identified in those screenings. Effect measured is this comment on whether it's possible to measure any impact that those variants have on those people on the degree of metabolic dysfunction. Direct or indirect means were they directly or indirectly measuring people that have Pompe? In this case, both are indirect because they're measuring carriers and then projecting Pompe diagnoses. Projection is the frequency. In this case, this is specifically prevalence at conception, which is subtly different than prevalence at birth, which is what we'll see in a minute. And the last 2 columns capture those statistical errors I mentioned, alpha and beta, and some analysis to say how good are these how good are these estimates based on the information at the time, or how good was the information at the time to make these estimates. And the ranges are what the stats tell us about where the truth is most likely to be, given the information that we had at the time. So from the first method there, if there was 1 million babies born, we'd guess that 31 have Pompe, and we're 95% sure that it would actually be somewhere between 4 and 267. For the second one, for those same 1 million babies, we'd expect 25 that have Pompe, and we'd be 95% sure that somewhere between 9 and 72 have Pompe. And a lot of us have maybe heard confidence interval before, and that's associated with alpha error, and that's what we just went over. But it's unfortunate that a lot of analysis stops there, because adding analysis for beta error, which includes alpha error, adds a lot of insight. So for those same 1 million births, the power at the 80% level for those estimates is somewhere between 0 and 880 babies, and 0 and 453 of those kids will have Pompe. And there's a visual of that on the right for those that get cross-eyed staring at numbers for too long, like I do, where the whiskers coming out of the red dot are showing the alpha range, and the whiskers coming out of the blue dot are showing the beta range. And you don't need to read all of it other than to notice that the beta error captures a lot more, is a lot more conservative case of the type of error that you can possibly have. So it's a lot higher uncertainty range. So if we fast forward here to the last couple of years, we've had an update to that same method that was used 20 years ago, 25 years ago, but with a lot more data. And this is coming out of a great bit of research by Dr. Park, where she used 154 variants identified in 141,000 people to generate her estimates. And we see what the effect of that has on the uncertainty. And if you don't want to read the numbers, you can jump straight to the plot on the right. The whiskers get really small relative to the first set of whiskers. And her estimate for prevalence at conception is 1 in 23,000 people. And then finally, the updated analysis that we're talking about here is based on direct detection of disease through newborn screening. And the stats take the uncertainty out of how many babies out of 1 million being born down to from 880 as the range of uncertainty to just 12. I can guess out of 1 million, plus or minus, like, within 12, what the correct number of people will have that will have Pompe. And so it's just it's not saying that any of these methods is bad, good, otherwise, and dumb. It's just that there's different amounts of puzzle pieces available when making those guesses. So you're probably wondering about what that has to do with puzzles. And so again, reiterate, I want to recognize just not how valuable the work was of those early 2 studies to identify a data-driven estimate of Pompe prevalence when so little was known. But I also want to acknowledge the authors of those papers, that they were both very responsible in acknowledging uncertainty, and that's something that I have a deep amount of respect for. I think it's something about the 2 of them coming in at the same period of time with the same general range of prevalence that caused such a durable response of that number, of that 1 in 40,000 figure, which is still being used today in many places, even though there's definitely stronger data built on newer information available. So all that said, I pick both of the authors of those papers for my puzzle solving team any day. They basically got way closer with very few puzzle pieces than any of us back when there was just that one blue piece floating around on slide 4. And they were even closer than they may have realized. The second paper there made an assumption that was quite reasonable at the time, which is basically that having 2 mild variants may not cause disease. And it's only in the last decade or so that we have enough information that has been identified to make it very clear that they do. And an aside there, even though some of our medical professionals unfortunately don't get it yet and are still living in this still single blue piece world, we now know, like, hey, look, if we're making guesses at what puzzles are and our lives are on the line, we want to use all the puzzle pieces, not just stick in the same mindset of that single blue piece world. And so the first paper, the Martinic method, made a choice to scale the carrier frequency observed by the known variants at the time. So they observed seven variants in the carriers, in those 928 carriers, but there was actually 29 variants known at the time, and so they scaled that. And so if we combined the best of what we know to those 2 methods, if just one thing was different, we would have had a 1 in 15,000 estimate 20 years ago. And the uncertainty was still very high back then, which has only been resolved with the direct method with getting, into the millions in the sample size. But you see what I mean about them being really good at puzzles. Is they were really, really close. They were a guess or two away from it. Much better than I could ever do with it. And now let's get back to our puzzle. So we have more information here, a lot more than was available at the time, and it's still just 24 out of the 180 pieces, but the picture is really getting clearer. And I told you don't need all of the pieces. Our understanding of what we're seeing dramatically improves with each bit of additional data. So we have more people now. We have more. We can identify that maybe it's a group. They're all coming together, so maybe it's a group photo, and some more information there. And on the last section, I promised a thought-provoking realization, but here it is. And comparing the actual prevalence that we now know from the newborn screening, or the very statistically backed prevalence from newborn screening, with the diagnosed estimates, yields the following thought. When we look at progression, there's this realization. All of our understanding of the natural history of Pompe in humans is based on intense study of somewhere between 1 and 5 of those 180 puzzle pieces that we had. And that's pretty remarkable when you think about it, about how much we've learned. So putting this putting some pictures to it for your imagination, putting that learning in the context of progression. Here's some concept of progression, and I found this first set of images so interesting. And you don't need a lot of training to see how different these two muscle fibers are. The one on the left looks really orderly and pretty, almost relative to the one on the right. The one on the right has a lot of progression of Pompe, and then this really the mind-blowing thing was pointed out to me by Dr. Rabin on this work, which is that both of these muscle fibers are from the same person with Pompe, and even from the same biopsy. And that started to shift my frame of understanding of progression, which at a high level looks something like this. Symptoms and disease progression are not the same thing. Symptoms only happen after the disease has progressed. Historically, we've been confined to only learning after people have had a severe enough symptom progression to give them a chance at diagnosis. And this commentary, this realization, the statement I made before that all of our natural history is based on 1 to 5 of those puzzle pieces, it isn't about undermining any of that effort or the intelligence or the quality of the information that is there that got us here. But it's to recognize that we have the opportunity to build on that, to improve our understanding with each new piece of information. And it's about trying to strategize how to uncover more puzzle pieces at a higher rate. So again, we've only captured the symptom onset at the bottom there. We can see that we've only captured this right-hand range in our natural history. So that's the basis for everything that we've learned from natural history. But we've also learned along the way that that timely intervention has at least 2 huge benefits. The possibility to catch the disease before more severe progression has taken place, both at an earlier stage in the cells, so further to the left in the top in that middle row, and then also fewer cells at advancing stages, so further to the left of the bottom row. The other thing that we've learned, which is really cool, is that improvement within cells is possible if treated prior to a threshold of advancement. And we don't know exactly where that threshold is, and it's going to evolve over time as treatments evolve and our understanding of the diseases evolve. So that's only going to get better with improved understanding of dosing and the disease itself, and with Gen 2, Gen 3, et cetera, treatments. And so having strong epi gives us strategic reference for how we're doing on diagnosis, how we study and understand progression and the underlying mechanisms, and how we develop treatments, including some that are imagined quite differently than a weekly or biweekly infusion concept, and how we develop guidelines for how those treatments achieve the best outcomes. The scary part is there's still a lot of uncertainty. We don't know the entire puzzle, but we're getting enough information now that we can start to project and actually strategize. Oh, I'm going to put together the edge pieces. I'm going to put together the corners. I know that these pieces go together up there. These pieces go together down there, and that's the strategy part of it. So back to our puzzle. I think I'm starting to know what it is now. And eventually we get to the point of there's our picture. And for some of us, picture was already we already knew the basic information about the picture. We knew that it was there was a sky above and grass down below and some people in it, and then those people were in the group, and it was probably in a nature setting because there's trees and all this kind of thing. And we knew quite a lot of information to take action with our guesses well before we got this whole picture. And that's really the journey that we're on together. So some summary sound bites from all of this kind of thing is that this prevalence analysis doesn't include the unknowns, meaning that the 1 in 18,000 estimate is a conservative ceiling. It will certainly move to a slightly more prevalent figure than that. My guess is that it'll move towards 1 in 15,000, maybe not get all the way there, but it won't go to 1 in 10,000 to give an example there. And don't worry, that's still rare. For reference, it would have to be like more towards like 1 in 2,000 to be considered not rare and therefore be disqualified from any kind of regulatory benefits of being rare. But what that also means is that we have 355,000 people worldwide that have Pompe. And by some estimates, we've had no more than 10,000 ever been diagnosed, and this is a really, really high estimate. Just to kind of, we don't need to be sporty on that estimate to prove the point that 10,000 compared to 355,000 is very small. And realistic, we have path to estimate that the number on treatment is closer to 2,000 worldwide. With the numbers as well, we can say that there's 7,500 babies born each year with Pompe, and 220 of those babies will be diagnosed at birth because they live in a territory or a country that have newborn screening for Pompe, and the majority of that's in the U.S. Another approximately 220 of those will be diagnosed at some point after progression is severe enough, and the rest of them won't get diagnosed unless we engage and do something about that. I've highlighted and bolded this one because these figures are really, really staggering and concerning for me. And they're a big part of where my passion comes from. And I hope the community will back me on that. When we talk about diagnostic odyssey, which is like a really common thing to talk about in rare disease, anything less than 29.6 years to diagnose for Pompe disease is mathematically wrong. Any number that you see that's less than that number is mathematically wrong. So again, these are just some tidbits that like to make a brain worm or an earworm or whatever the nice word is there to hold on to that you'll hear as you go around the rare space or as you're discussing with colleagues or other doctors or whatever else. And then the last one for me that's really important is that the 1 in 18,000 figure. It's really important because I think a lot of people don't realize it. The 1 in 18,000 figure is for total prevalence, and it applies worldwide. It is statistically the strongest and therefore best estimate currently. I hope we have better estimates really soon because we're getting new data all the time. But currently, any figure other than that is less statistically strong than 1 in 18,000. The interesting part is that for that 1 in 18,000 figure and why we can apply it worldwide is that for this data set of 12.6 million newborns, we cannot conclude from that data set that there's any difference in total prevalence based on where somebody is, where somebody's born. And so if somebody, again, if you start to see presentations that if you continue to see presentations that say, oh, it's different here or different there, respectfully ask the presenter or the person sharing that information to see the power analysis for that suggestion, And like we want to correct that, and there's some really important reasons why. I will note that there are differences. There are some differences seen, and the data does support that there are differences seen in the distribution of severity across the disease spectrum, and that makes sense in some with the other piece of information that we know that some of the individual variants that are disease causing have different prevalences in different different areas. So again, all of this stuff, it's not just about industry strategy or strategy for engaging the folks that are developing treatments. It's about overall strategy for the health of our ecosystem. And there's some subtle things in here. So on that last point that I said, the evidence that there's global convergence on total prevalence, even when there are acknowledged differences in individual variant prevalence, says something interesting about the underlying metabolic process, possibly on an evolutionary scale. That's not going to help us develop treatments in any near time, but it is a thread to pull for an academic research, and we're engaging colleagues in academia to help with that. The other thing I want to point out here is a big concern about U.S. versus worldwide projections, or how I see it based on the work in this study. So the U.S. is about 4% of the world's population, but is currently 50% of the market for Pompe treatment. Going forward, the U.S. is diagnosing in the high 90% of kids born with Pompe. So like of all the kids born in the U.S. that have Pompe, high 90s of those, like 90, 95, 96, 98% of those kids that have Pompe will be diagnosed at birth. But most of the world is still below 10% in diagnosis at all, and less than 2% in diagnosis at birth. So that emphasis on US only is only going to grow, and that's really great. We want kids to have the best chance, and in the US and Taiwan and other places where they're doing newborn screening, that's happening. But we can't put on our blinders to that same problem, that same rally cry that we shouldn't have death or disparate health by zip code or by state in the US that help to push newborn screening. We also shouldn't have it by country. And so we really need to rally as a global community to support each other, not just in the US centric ecosystem, focus only on the US. So now some closing soapbox thoughts. The main one is that it's okay to ask for puzzle pieces, and it's important that we all do. Curiosity is what makes evolving our understanding possible and what makes improving our future possible. Hopefully I've convinced you all that we should seek new information and, importantly, use that information to evolve our understanding. Where we are at now is built on many generations of curious and passionate people that have laid an incredible foundation for our community, and we're really primed to accelerate from here, but it's up to us to do so. We've learned from all this that Pompe disease is a spectrum, or we've confirmed the hypothesis that Pompe disease is a spectrum, and that time of onset categories are misleading because we have detectable onset of progression at birth in every single case. So all of the cases identified in newborn screening have addressable disease. They don't all have the same severity. And the data and disease understanding that supports this learning is strong enough and robust enough to compel the conclusion that 100% of those cases have Pompe disease that is addressable. And again, don't need to get emotional about it. If there's anybody that disagrees, let's just pull our puzzle pieces together and put them on the table and take a look at the picture. We owe that to the people that we're serving. We owe it to not hold on to just that single blue piece at the beginning and be unwilling to change our guess, change our view of what the picture we're seeing is. In recognition that Pompe disease is a spectrum and timely diagnosis affords new opportunities, it's worth it to differentiate a threshold of detection, and we want to move that as far forward as possible with a threshold of action. And we want to figure out what are the most responsible and engaged ways that give people agency over their decisions of when to start treatment or what kinds of treatment to go on. And to the point there, from the industry side and the partnership side, We've got multiple modalities. We've got improved treatment logistics supported by improved efficacy, and et cetera, that are all in work and aligned with this model. And again, just to reiterate, because I think it's so important, our opportunity to really create a better future for ourselves and our community is only realized when we lift the entire community around the world and across the entire disease spectrum. And I'll stop, and hopefully there's questions.
Thank you, Ryan. I think that was a very fascinating presentation. I'm going to go ahead and kick things off because I do have one question. You said that the diagnostic odyssey, that time should be considered 29.6 years. Can you explain how you came to that?
Yeah, I didn't want to make the wedgies a certainty by going too nerdy on everybody. But it's really quite straightforward. When we look at the total diagnosed estimate, even at 10,000, which is a way overestimate, versus the total that actually have disease, we can say that there's that it's like 3% of the people who actually have Pompe have ever been diagnosed. And so if we assumed that all 3% of those people were diagnosed at birth, which is again a generous assumption, we would do a weighted calculation to say that the average age of the 3% is 0. And then for the 97% that haven't been diagnosed yet but have disease, what is the average age there? And so the average age in the world is 30 point whatever years, 31 years. And so it's basically 97% times 30 for that average plus 3% times 0 to get that number. In the US, the number is a bit higher because the average age in the US is a bit higher. But again, that's how we can mathematically be certain that anything lower than that from the onset of progression, the onset of disease, to the time of diagnosis is at least that number. And I can't hear anybody if you're talking.
Sorry, yes, I was. I was going to say onset of disease or onset of progression because you said, did you say that progression comes first and then symptoms?
Yeah, so there's a good bit of language there that I'm really trying to train myself to be more consistent on, and I'm hoping
Mhm.
that will take. So for me, onset of disease is the onset of progression.
Mhm.
Onset of symptoms is different. So symptoms, if we're being really specific about it, symptoms means when I feel something. It's required that I notice that something's going on. So
Mhm.
in that sense, like again, somebody who's being really specific about about language, it might be impossible for a baby to feel symptoms depending on what you can interpret from a cry. Here nor there on that one. But from the onset of disease, we know that I mean, newborn screening is specifically built around detecting metabolic dysfunction. In most places that do newborn screening, the first tier of that screen is detection of low enzyme activity of the enzyme that is coded by the gene that causes Pompe. So right off the bat, we know that there's disruption to metabolic function, which is the start of the disease cascade. From there, we've got a number of opportunistic biopsies that have been taken, and some of these are published as far back as 15 years ago, and some of them are more recent. And I will encourage those who have them to hurry up and publish them because I think it's really compelling. But opportunistic biopsies of kids who have late onset genotypes, but detectable disease at a cellular level within months of life. And then we have the observational studies that have been both have been published, or two of them have been published by Rarekar et al. And by Huggins et al. That look at cohorts of Pompe kids who are newborn screen diagnosed to see what Pompe specific features of progression, whether they be by a biomarker that or kinematic or whatever else, are detectable, and how early are they detected? And 100% of the kids in those cohorts, and this is on this off the top of my head, maybe 40 or 50 kids, have detectable features of Pompe disease early in life. Not all of those might be actionable just yet, and that's where that distinction between detection and action
Mhm.
comes. Some of them, it might be very, very slight, and the consequence of waiting another couple months, couple years is relatively low, or waiting to see what happens. Obviously, we know in the more severe end of the spectrum, you can't go fast enough. Days matter, and we've seen, we're all, I think, watching with bated breath, and really warm hearts, that the study that's going on with the prenatal ERT,
Mhm.
that's yielding really quality results for that family, and great learning. So across the disease spectrum, we know that everybody has something that is actionable. The cool part is, in the future, it might not be that everybody needs to do if a more milder progressive path. If your rate of progression is slower, you might need to take a different course of action than somebody who has a more rapidly progressive path. But the starting point of that progression is as soon as that metabolic process is called to action, which is sometime
Mhm.
pre-birth.
We have a couple of questions. What about elevated biomarkers, but the person does not feel symptomatic? Do you consider having high CK X4 not the same as having symptoms?
Technically, that's not the same as having symptoms. Those are perhaps clinical findings or observations, but they're not the same as having symptoms, and that goes back into that same those are signs of progression. They are evidence that within the body something is happening different than expectation, and that so while those are signs of progression, they may not meet the threshold that individual, or with whatever information they have on their hands, and consult from the medical team that they have, that may not meet the threshold of action for them. They may want to wait till later, or they may say, we may learn to evolve that. I mean, I can say from that one slide that shows progression within the cell, there is a point at which um, even the current ERTs, the current treatments that we know are life-saving and are wonderful, but we hope that future ones are a lot better, and there's good signs that there will be. Even those ones can reverse some of that damage. So some people might take the approach of, why would I wait till there's such damage that I'm having outward symptoms, or whatever else, that and take the risk that they might not be reversed. What does that trade-off look like for me? And that's a personal decision. But for me, it's all about having the most amount of information to make that decision from an educated perspective.
Um, Thank you. And then Brad says, I agree with everything you're saying. My concern is the freak out factor that payers will have when they do the math. The model we currently have for paying for these very expensive drugs will have to change. And before you answer that, I'm going to just remind everybody, if you have any questions, please type them into the Q&A box. So then
Uh,
over to you.
I share your concern, Brad. It's a um, if everything stayed the same, but we got really good at diagnosis, it would we'd break the system. But the good news is, everything changes. All of our assumptions about pricing and about manufacturing also change with updated epi. And I'd rather walk forward, perhaps cautiously, and find the right people to walk alongside on that journey to figure out what forward looks like, rather than sort of pretend like it's not real, and ignore it. I think that there's really productive discussions that can happen with payers. Um, I think that there's really productive discussions that can happen with developers and manufacturers of drugs. That, again, if you're making something that is you're making 10 times the number of thing of that thing, or 40 times of the amount of that thing that you currently make. The way you do it's going to change too, and economies in scale in manufacturing are really a well-known, well-modeled thing. That then pulls the thread to, is it scary for disincentivizing pharmaceutical companies for that, and it shouldn't be. We currently have sort of a billion dollar a year plus market for treatment of those 2,000 people with Pompe disease. If we got really good at diagnosing Pompe, even if the average cost of treatment came down by a factor of 10, we're going up in diagnosis by a factor of 20 or 40. So there's still billions of dollars a year of revenue, even at a 10 times cheaper treatment per year. And that's not even considering treatments that, and the 10 times cheaper doesn't mean that it's just like lower margin per ounce of treatment made. With more effective treatments, we can consider less frequent dosing, or alternate or lower dosing, and those kinds of things that still achieve improved outcomes for people with Pompe disease, but also help to make good business sense. So I'd rather tackle those head on. I want to work with industry. I want to work with regulators, with payers on all of that. I think that's something that our community can do, and we're really primed to be the glue that brings everybody together to do that.
Definitely agree with you there. George has a question. Do you think it's possible that someone discovered with newborn screening would never need or want treatment? And he also said, awesome presentation, Ryan.
Thanks, George. Need or want are two different things. And I'll introduce the third one just to kind of avoid answering your question. I can't answer for want. And then need is, I think need is a personal decision on like what's on the other side of the coin. For me, I think the data has been really strong to show that every single person diagnosed with newborn screening, and a lot of those unknowns as well, that are in waiting, every single one of them has progression that could be positively affected by some form of treatment. As we learn, that treatment they might get enough out of something different than an every other week infusion. They might get enough out of it, out of a different kind of treatment, but every single one of them will have could benefit from it. And I love that they have the option then to decide when to take action to realize that benefit. And that's what I want to work towards, is that people have agency, rather than, like, I think for a lot of us, that feeling of being diagnosed puts you in a car where you're a passenger, and you're like, you have no sense of, you're trying to make sense of where you're going and what's going on. And I think this helps put you back into a driver's seat in your own life.
To play devil's advocate a little bit, I think we both know that one of the criticisms of newborn screening for Pompe is that it does pick up late onset, which I agree with you. We need to be capturing them. But they always point to the example of the person that is not, quote unquote, symptomatic until their 60s or 70s.
Yeah, that
And
person
what
doesn't
does it,
exist.
there are still people diagnosed in their 60s.
Well, I guess let me rephrase that. Sorry, I cut you off. Let me let you finish, and then I'll rephrase what I said.
Okay, so and then they point to the fact that they get diagnosed much later in life, or they get diagnosed early, are symptomatic much later in life, but have the diagnosis hanging over their head for a very long time.
Yeah.
And again, this is devil's advocate because it's not an argument I agree with at all.
No, I know where you're coming from on it. No, it's an important one, and again, this is an important, having these kinds of discussions and devil's advocate is an
Mhm.
important part of, let's put our puzzle pieces on the table together and
Mhm.
talk through what we see. So for me, it is possible that somebody goes their whole life without being symptomatic. I've watched presentations at the AMDA conference
Mhm.
where we saw somebody walking on the screen that was described as an asymptomatic person, and I think every single one of us in the room could see that that person walking has progression of Pompe, um, clinically observable at a distance without taking blood, without even being in the same country, observable progression
Mhm.
of Pompe. Now, if they don't feel that they have symptoms, if they feel they're living their life the way that they want to, I think that should be their choice to
Mhm.
continue on however they want to. They don't. I would never. This goes back to the question from George. I would never say that they need treatment, and we should force them on it. Um,
Mhm.
but I think that the other part of it is like, well, is there a burden to knowing? And for me, if I take the emotional part of being diagnosed with this thing that there's not a lot of information at, or it feels very scary out of it, like, is there a bad part to having more information? And philosophically, maybe, but like, generally speaking, I think most of us would prefer to eat our meals with our eyes open and our noses open so we can see what we're about to put in our mouth. It is great to have the information. I think the opportunity there is not to filter the information or to withhold information from people. It is to evolve the narrative and the
Mhm.
discussion around what that information is. And so, um, it's a very crude example, but you know, when you're buying a used car, at least in the States here, one of the car companies used to have this thing where, you can buy with confidence because it has a 128-point inspection. And so, like, this car has been inspected by an expert, and now you can feel confident in driving it. That's the same thing.
Mhm.
That's knowing going into this, that what to expect out of what you have, um, and evolving the picture. Like, we still have a lot of literature out there, and we when new people show up in the Facebook groups or whatever, and the first information is don't Google it, this and that. That's tantamount to that's equivalent to this puzzle analog saying, don't look at Google, because those are all from a date point where we only had three puzzle pieces. We have more puzzle pieces now. Like, let's take on the challenge to modernize our view, to look at the pieces on the
Mhm.
table, to collect more pieces, and then look at them again, and make this thing less scary than it has to be, but give the right information to give the appropriate amount of urgency for the people that need that urgency.
Yeah, and Allison's question goes right along with those lines. Because I see parents of babies diagnosed via newborn screen and they're freaking out because they don't know what to do. There needs to be more information for them instantly. How can that be ensured to happen alongside diagnosis?
I'm picking up my magic wand later today, so collect your wishes, send them to me, and we'll wave it, and we'll have it done. Um, I, I I don't know. There's a bunch of I mean, I have ideas about this. There's a bunch of other folks that have even better ideas, and I think we if this is something that you're passionate about, like, let's work together to achieve it. For me, one of the strategic points might look like, um, one of the ways that we do education around diagnosis right now is directly to physicians, and there's, um, strategically, the epi shows us that is probably not a great strategy. There's too many physicians, and the likelihood of them having Pompe, and the likelihood of them in their employment structure being able to put enough time into becoming an expert on Pompe is is just not realistic, and that's not a knock on the quality of your physician. Um, so how do we go direct? But how do we get information to people? How do we get the right information to people? How do we get it directly to them? I think it's two parts. One is oversimplified. It's what is the right information for people, and that might be changing by the person. And then also, how do you get it to them directly? Working with newborn screening programs, working directly with state departments of health, or national health programs that are administering newborn screening seems like a good way to do it to me. That only addresses the 7,500 kids being born each year. It doesn't address the other 355,000 that we hope to get better and better at diagnosing over time. So we also need to work with what are the funnels that we have in our community to bring people to a common place where they can get the most kind
Mhm.
of information. And like rather than having to educate everybody to become an expert, how do we like educate everybody that a resource exists and or a set of resources exist and funnel that to a single place where like, okay, cool, here's your community, here's where you can always come to for the latest information, here's this organization or that piece of literature or that scientist who's doing great work that you can tap into to help build confidence back after such a scary diagnosis.
Yeah, and I think, in the US, we do have the option, if we can figure out how to team up state by state, that parents get pamphlets from the doctor all the time when there's the diagnosis. So why couldn't there be one specific to Pompeii with the relevant, up-to-date information?
Yeah, for sure. And this isn't we have a really incredible community in Pompeii. We have an incredible history, and I think it's actually a great role model and learning reference for a lot of things in the broader rare disease community. But reminding us that we also have the broader rare disease community to leverage for relationships, for ideas, for looking at what worked, looking at what didn't work, and then also to keep in mind as we're developing strategies. So for me,
Mhm.
whenever I think about a strategy, I try not to think about will this work for Pompeii, but also does it scale for, I mentioned earlier, does it scale for the entirety of the world relative to Pompeii? Does it scale for the entirety of the disease progression? And does it scale for rare disease in general? And those are the ones that tend to weight higher in my mind when I'm doing when I'm prioritizing what strategies I consider.
Well, and I think we should also ask at the fourth point, what are other rare disease communities doing, and can we piggyback off of those efforts?
Yeah, for sure.
No need to reinvent the wheel. So,
Yeah, there's definitely like different layers to community, different layers
mhm,
to this whole thing. We've obviously got our patient community, but then we've got the broader Pompeii community, and I make sure to when researchers or industry refer to you guys as community, I make sure to let them know that they're part of it too, and you're
mhm,
right here alongside me. And if you're not right here alongside me and us, then then get here because that's what we need. But then we have the broader rare disease community, the broader humanity, blah blah blah.
mhm. All right. Do we have any other last minute questions? Any other things you want to pick Ryan's brain about? We've got like a minute left.
That's not enough for one of my answers.
No, not really, right? All right. I don't see anything popping up. So, with that, I am going to say thank you to Ryan for this great presentation. And thank you to everybody for your questions and participating. This will be up on the AMDA website very soon. And in addition, just have a little plug for the AMDA. Earlier this year, we had a really great webinar, The ABCs of Pompeii, with Erin Huggins from Duke. So it's a great resource for new families. Um, all right. Thank you so much, Ryan, and thank you for everyone. This will end today's webinar.